All right, so for this one, we're asked to sort these series in order from least to greatest based on their sums. So this is what we call summation notation. So I'm going to take the first one and I'm going to jot it down over here to the right so you could see what we're doing. So let me explain to you what this means. So this is referred to summation notation. So we're going to say summation notation. And the way summation notation works is you have a geometric sequence. Of course, this will work with an arithmetic sequence too, but you're going to have a sequence that's generated by taking one number and multiplying it by a common ratio several times. And then from there, you add them all up. So if you notice the first three problems, we had a sequence, we added up the sequence for the practical application. So what this really means is, do I have enough room? No, it means what I'm going to do is I'm going to take 27 times 1/3 raised to. So what I'm going to do is I'm going to take, and I'm going to start from 0, and I'm going to plug the 0 in for k. Now, because it's summation notation, I'm going to add that to the next term, which is 27 times 1/3 raised to the first power. Okay? And then I'm going to add 27 times 1/3. Actually, I'm not going to have enough room. So I think I'm going to have to shrink my thing a little bit here. I'm going to shrink this down a little bit to give myself a little bit of room. All right. So this is the same as saying 27 times 1/3 raised to the 0 power plus. So I'm just going to cycle through 1, 2, 3, all the way up to 6. So I'm just writing down 27. So remember that with our recursive notation, we start with the first term, right? And then we multiply in a geometric sequence. We multiply by our common ratio to get the next term. And then when we convert that to the explicit form, it's just the first term times, man, I'm still not going to have enough room. You got to see it all in one line. I got to move this out of the way. So it's always going to be the first terms times the common ratio raised to the n minus 1, right? And so that's what we're doing is we're taking this explicit form, but we're using it to get all of the terms. So this is my first term times the common ratio raised to the 0 power plus my first term times the common ratio raised, or I'm sorry, that was to the 0 power. This is to the first power. My first term times the common ratio raised to the second power. My first term times the common ratio raised to the third power. My first term times the common ratio raised to the fourth power plus my first term raised to the common ratio to the fifth power plus my first term times the common ratio raised to the 6th power. So what we're doing is we have 0 to 6. That comes from 0 to 6. So we're cycling through and putting 0. In other words, in here we put 0, then we put 1, then we put 2, then we put 3, then we put 4, then we put 5, and then we put 6. So now what I got to do in the next step is this is the actual sequence. So I'm going to do this one problem, and then I'll show you the shortcut. So I'm going to say 27 times 1 divided by 3 raised to the 0. Okay? Now that'll be 27. The reason that it's 27 is because, one, you got to follow order of operations. 1/3 times 0 is 1. 1 times 27 is 27. So we got 27 plus 1/3 raised to the 1st power is 1/3. 1/3 of 27 is 9. But we'll verify on the calculator. So now what I'm going to do is I'm just going to go through here and I'm going to change this to a 1, then hit enter. That's 9. Okay. Now I'm just going to go through and do the whole sequence. So if I hit second, enter, that gives me the second entry, and then I'm just going to edit this. So when I put that like that, that gives me 3, because you're really dividing 27 by 9. All right. Then we're going to do this again. Second entry. I got to adjust that to 3. So that's going to give me 1. Now, if you notice, the pattern is we're dividing by 3 every time. So this next one should be 1/3. And so how many is that? That's 1. We've got 1, 2, 3, 4, 5, 6, 7 terms. And right now we've got 1, 2, 3, 4, 5, 6. So this will be this. And this should be this. Okay. So if I do this again, second entry, change that to 4. Oh, not 34. Forgot to delete delete that. So that's 1/3, right? Second entry. I'm going to change this to 5. Oh, I almost did it a second time. Now that's 1/9. You don't realize it, but I can tell you, I can show you. If I hit math and the first term convert a decimal to a fraction, if I hit this, it's 1/9. Okay. So the next thing that I'm going to do is now I got to type it in again, 27 times the quantity 1 divided by 3 raised to the, now we got to do 6. That should be 1/27. How do I double check? Hit math and then convert that to a fraction. 1/27. So we're not quite done. So the next thing I got to do is add all these up, because the sum is the answer to adding all those up. So I'm going to, in my calculator, add them up. So let me get the big part of the screen so you can see it. 27 plus 9 plus 3 plus 1 plus the quantity 1 divided by 3 plus 1, the quantity 1 divided by 9, because that's what a fraction is, plus the quantity 1 divided by 27. We're going to get a decimal, I think. So it's 40 something 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 as a decimal. So now I'm going to convert that to a fraction by hitting math. First option, convert. This means convert to fraction. And it'll probably be an improper fraction like that. You can actually convert those too. So if you hit math, and I think it's under number. Oh no, fraction. If you go to fraction, I can convert that. An improper is the one on the bottom here to a mixed number, right? So if I do this, it'll say 40 and 13. But you know what? I'm going to go with the decimal because for this problem, we're just putting them in order from least to greatest. All right. But before I do that, so I know that the sum of this is 40 and 13. I'm just going to leave it as a decimal. That was a 40.481. All right, but there's a shortcut for that, and that shortcut is called summation notation. So I could do all of that work by plugging it in my calculator. And so if I hit math again, see how this has summation? So if I hit summation here, I can literally enter that in. So I'm just going to use x instead of k. Our lower boundary is 0. Then my upper boundary is 6. Then I'm going to put in 27 times 1 divided by 3. Now here, I got to put the parentheses in there. So I'm going to have a lot of parentheses because and then I'm going to put an X here. So as you can see, it looks basically identical to what I have written down here. All right. So that's what we're going for, is to make this look exactly like this, except this is going to be in parentheses when you put it in the calculator. Okay. So now if I've done all my math right, when I hit enter on this bad boy, I should get this same answer here. So let's see. Oh, I almost turned the calculator off. See how quick that was? So now I can very easily figure out the rest of these by just plugging them in the calculator. So I can plug this one in the calculator, 33 to the 1, or raised to the 1/2. So if I want to find the next one, then I just hit second entry. And now what I'm going to do is I'm going to change this to a 2 and change this to 33. And that'll give me the summation for that one. Okay. And then my last one is going to be from 0 to 5 of 50. And then my common ratio is 1/8. And same thing with that one. If I just hit enter, it'll do that whole process and give it to me that way. So if it says to write these from lowest to highest, I would say that this one is the first one, right? Then the second one is this one, and the last one is that one, if you were writing them in order. I could just take pictures and put them in place. So this one goes here. This one goes there. And then this one goes here. I think, let me double check. We want to go from greatest or least to greatest. So the 27 one goes first. Then the next one is the 50, and then the last one is the 33. Yep, that's right. I'm going to take a screenshot of this though and incorporate it in the notes. That way, if you guys need to look at it. Okay, and that's it. That was a long one.